Hello and welcome back. So far we have done the hypothesis testing and understood which categorical variables are strongly correlated or which categorical features are strongly correlated with the target variable. Here variables or features or columns are synonyms. Okay. So, and then we did the label encoding and one-hot encoding accordingly. So we are doing a rigorous EDA and trying to build a model and see whether model performance improves or not. Okay, this is the process of building a model. You build a model and strive to make the model the best. Okay, so we are in that process. We have seen the learning curve approach and gradient, the grid set CV approach, and we will use grid set CV approach in selecting models, best model from now on. So here we have imported the pipeline and grid set CV again, right? And then we have created a pipeline with polynomial features and linear regression. As we have understood this before, the pipeline is a sequence of data processing steps. Here, when you have to build first degree, second degree, third degree, and fourth degree polynomials, each time you pass data to the linear regression, you need to call or invoke the polynomial features class and pass the degree to it, transform your data into that degree polynomial and pass it to the linear regression, fit the model, or train the model, right? So that can be done easily using grid set CV, which actually uses the pipeline to execute the steps in a sequence, right? Not only that, it actually does the cross validation also, k-fold cross validation also, right? If you see here, when I said poly LR regression pipeline, it has got two steps, and the param grid has got the degrees which we wanted to pass it to the polynomial features. So here the polynomial features is the variable name underscore, and then you specify the degree. That means you are trying to pass these values to polynomial features one after the other. How it will work is grid set CV will take the polynomial features pipeline, take one from the polynomial param grid, go to the pipeline, apply first degree, and then pass the data to the linear regression, and then fit it. When you say grid set.fit, that's when it happens. Okay, it passes the x and y both to the pipeline. In the polynomial features, it knows that it need to use only x, and it passes the 1 and then transforms the data and passes the transformed data to linear regression and fits it. And it does a cross validation on the first degree polynomial. 3, k is equal to 3. That means it will build 3 models. And test it on cross validation set and calculates averages and all that, right? And then it takes the 2 and then calls, passes it to the polynomial features. When you say fit, that's when it is happening. It passes to the polynomial features and transforms your data into second degree, and then passes the transformed data to linear regression and fits it or trains it. Okay, again 3 and 4. It's going to build 12 models, but it is going to ultimately get 4 means of train and cross validation, whichever are high and close to each other, the cross validation and train scores. It is going to choose that model as the best model. The best estimator is nothing but that. Okay, if you want to see the parameters it chose from the param grid, the best parameters it chose from param grid, you can find it using param grid also. Param grid underscore is a param underscore best underscore params underscore is a attribute in grid set which gives you the best parameters. So let us execute this and see what happens. Right, it will take a little while. Right, it actually chose the second degree polynomial as the best polynomial, right? And then let us try to run this. I've got 91% accuracy only, right? So this looks like not a good model, because on the linear regression model, on the third degree polynomial, we have got 98% accuracy. We have seen that, right, before. So there must be something wrong, right? There must be something wrong with either the parameters we pass to polynomial features or the parameters which is taken by the grid set CV. So here we have taken, I suspect that the CV is equal to 3 may be causing the problem. Okay, so we built a model and we are trying to assess where the problem is so that we can fix it, right? It is always about that, right? So here the cross validation is 3. That means what happens? On the train set we have got 1209 records. When you say cross validation is equal to 3, it is going to take 403 records for cross validation and rest of the 806 records for training. Right? When you have 1200 records, the data set is small and you are wasting lots of data for cross validation. You are keeping that data aside for cross validation. Right? Maybe that is causing the problem. The model is unable to understand the pattern and it thought that the second degree is the best one. Maybe it has got that one is the highest average scores and maybe they are the closest. So let us try to change it to 10 and see cross validation 10. What happens? 120 records it's going to take as, because cross validation 10 means it splits the data into 10 pieces and it does 10 models. First piece cross validation, 9 training, second piece cross validation, rest of the 9 training, like that 10 models it will build and take the average, right? When we split data into 10 pieces, we will get 120 records as the cross validation and rest of the 1000 and odd records, 1080 records as train set. So you pass more data while training, the understanding will be better. Maybe it will choose the third degree polynomial. Let us see. I have given cross validation is equal to 10. Now it is going to build 40 models, but out of 40 it's going to extract only 4 pairs of scores, train and cross validation. So it got third degree as the best model. See this, the hyperparameter tuning is one of the kind of hyperparameter tuning is this. We will talk about hyperparameter tuning in coming classes because hyperparameter tuning is the key for deep learning and other advanced models to get more accuracy. So we are actually moving towards that. So when I changed cross validation to 10, it chose the third degree as the best model. Let us try to test it with the best estimator. Best estimator here is third degree polynomial now, right? So you got 98% accuracy, right? So the cross validation makes a lot of difference. That's what you need to see. When you take the cross validation more, even when the data set is small, it is going to understand pattern better. Because when you take cross validation size, the number of k size more, you will get more data for training. I hope you are understanding this. So let us try to test this on test set. We need to apply all the transformations which we have applied on the train set, and then we need to predict it with the best estimate. We have got only 96% accuracy on the test set. It's a bit overfitted model, but maybe you can play with the other one hot encoding and label encoding and other features, right? Other features, and try to do more feature engineering, and maybe you will get the same accuracy as 98% or maybe more than that also. So I would suggest you to play with this file and try to improve the accuracy. Thank you.